So what we need to do is solve the rational equation k over k plus 2 equals 4 over k squared minus k plus 6 minus k over k minus 3. Now the trick here is we have two functions or two terms that are set equal to each other. So we're going to graph each term in Desmos. So for this term and this term, I'm going to graph in Desmos. So when I open up Desmos, follow along and help read off what I need to solve. But now instead of variable k, I'm using the variable x because Desmos recognizes x. What's the first equation? Right, so I'm going to have x over x plus 2. And what's my, and I'm going to have to zoom back in to a normal. All right, x over x plus 2. And what's my other equation? X squared minus x plus 6. So what else? Minus x plus 3. X minus 3. So check this out. And here, I guess this is a typo. Switch your sheets to x plus 6 to x minus 6. And that's just going to make, I just knowing the question on the midterm, that's going to make this better aligned to your midterm question. So now, instead of x, k, that's going to be minus k minus 6. All right, now this is going to be x minus 6. So the intersection of the two lines is where the two lines equal each other, and we're trying to find the x value where they're equal to each other. So just find the x coordinate at the points where the two functions are equal to each other. So we have negative 1.186 and 1.686. So when we graph this in Desmos, I have one function. The critical point of intersection is I have one function that looks like this, another function that's looking like that, and I have an intersection point. I have one point which is negative 1.186 comma negative 1.457. So I'm just showing you how you would show your work if you're showing your work on a common assessment. And I have 1.686 comma 0.457. These are just the y values that both of these are equal to at the x values that make them equal to each other. So our solutions here are 1.686 and negative 1.186. And these are two solutions for k. Because if k is equal to these values, then these are the values that make these two equations equal to each other. And now I'm just going to quickly go over, and so this is the way you should solve it, but I do want to show you guys the method you do to solve this if you were solving this the way that I originally taught you. So it'd be k over k plus 2 times k minus 3 over k minus 3 is equal to 4 over k minus 3, k plus 2, that's k squared minus k minus 6 factored out, minus k over k minus 3 times k plus 2 over k plus 2. And this gives us a common denominator to factor out, so having k squared minus 3k is equal to 4, but because we're subtracting this term, minus k squared minus 2k. And so I end up add k squared, add 2k, subtract 4, so I end up getting k squared plus negative 3k plus 2k is plus k minus 4 is equal to 0. And now I just need to find the zeros, the values of k that make this equal to 0 are, I'm sorry, this add k squared, that creates 2k squared, add 2k, that creates negative 3k plus 2k is 1 plus k, and then subtract 4, that's negative 4. Now, 2k plus k minus 4. I need to find the values of k that make this equal to 0. So I graph in Desmos 2x squared plus x minus 4. Two x squared plus x minus 4, and my values are negative 1.686 and 1.186, when those are the same values. So I would have from Desmos oh, I'm sorry, this is negative 1.686, 1.186. So we have negative 1.686 and 1.8, oh sorry, 1.186, 1.186. And actually that's positive. So I just didn't copy those problems, those values down right. But in general, from Desmos, these are our solutions. All right.